Hey guys, a very good evening everyone and welcome to another session of our domain analytics. So we have been discussing about this particular domain, capital markets. So today in the capital markets, we will be discussing about how to perform the K-means clustering. The data set that we are going to use is pertaining to our stock exchange. So let us quickly start and try to understand what is K-means clustering. When we talk about K-means clustering, or even when we talk about clustering, so even before we talk about K-means clustering, guys, let us talk about clustering. Clustering is the immense pool of technologies. It is the immense pool of technologies to catch classes of the observation, which are known as clusters. Clusters under a data set which is provided. Okay. Which is going to contribute to your identical features. Clustering is arranged in a way that each observation in a class possesses similar characteristics and observations of the separate group shows this similarity in the characteristics. So these are the three clusters which you formed on the various data points that were there in a given data set. The idea behind the clustering says is the data points which are together in the cluster, they will be having maximum similarity. So within the cluster, there will be the maximum similarity. And between the clusters, you will be having maximum dissimilarity. Within the clusters, you will be having maximum similarity, and between the clusters, you will be having a maximum dissimilarity. This is the idea behind clusters. It can be used for various things like segregating the customer base, right? In the bank, people are there, say students are there, and business owners are there, and government officials are there, and you come up with a student loan. Your bank comes up with a new product in the student loan. Now, promoting this particular product to each of these people doesn't make sense. This is one big data set. So you perform clustering over here and you come up with various clusters. This is say students, this is business owners, this is government officials. Now placing this product at this segment for the students, it makes more sense. And that is the idea behind your clustering. Again, when we talk about clustering, it is divided into two parts: unsupervised and supervised. Unsupervised clustering method. In this, clustering attempts to identify a relationship between data points without being trained by the responsible. Whereas in your supervised learning, the machine is getting trained, or your machine learning algorithm is getting trained on the patterns. Basically, in the process of clustering, one can identify which observations are alike and classify them significantly in that manner. Keeping their perspective in mind, K-means clustering is the most straightforward and frequently practiced clustering method to categorize a dataset into a bunch of groups, or your K classes also you can say. K-means clustering explores, or K-means clustering algorithm rather, it explores for a pre-planned number of clusters in an unlabeled multi-dimensional data. It concludes this via an easy interpretation on how many optimized clusters can be expressed. Primarily, the concept will be in two steps. Firstly, the cluster center in the arithmetic mean of all the data points associated within the cluster. Secondly, each data point is adjoined to its cluster center in the comparison to other cluster centers. Now, let us proceed further. So, K-means clustering is a simple unsupervised learning algorithm that is used to solve clustering problems. It follows a simple procedure of classifying a given data set into a number of clusters defined by the letter K, which is fixed beforehand. You have to choose beforehand. The clusters are then positioned as points, and all observations are data points are associated with the nearest cluster. Computed, adjusted, and then the process starts over using the new adjustment until a desired result is reached. K-means clustering has uses in search engines, market segmentation, statistics, and even your estimate. Market segmentation. And this is where we are going to use our use case for today, capital market. And we will be dealing with National Stock Exchange data set. Now, algorithm. The algorithm, K points are placed into the object data space representing the initial group of the centigrades. Each object or the data point is assigned into the closest K. After all objects are assigned, the position of the K centroids are recalculated. Step 2 and 3 are repeated multiple times until the position of the centroids no longer move. They will be moving from this cluster to this cluster, from this to this, from this to this, so on and so forth. So until and unless it doesn't stop moving, you keep on repeating this. In simple terms, your K-means clustering enables to cluster the data into several groups. By detecting the distinct categories of the groups in the unlabeled dataset by itself, even without the necessity of training the data. This is your centroid-based algorithm, such that each cluster is connected to a centroid, while following the objective to minimize the sum of the distances between the data points and their corresponding clusters. As an input, The algorithm consumes an unlabeled dataset, splits the complete dataset into k number of clusters, and iterates the process to meet the right cluster. And the value of k should be predetermined. As I told you, that you have to choose your k value beforehand. When we talk about the features of your k-means clustering, k-means clustering is very smooth in terms of interpretation and resolution. For a large number of variables present in the dataset, k-means clustering operates more quicker than your hierarchical clustering. While redetermining the cluster center, an instance can modify the cluster. K-means reforms compact clusters. It can work on the unlabeled numerical data. Moreover, it is very fast, robust, and uncomplicated to understand, and yields the best outcome. When data sets are well distinctive, that is thoroughly separated from each other. So here, if you see, this is how your k-means clustering algorithm is working. It starts, number of clusters you have to define before it. Centroid value is chosen, distance between the objects to the centroid is calculated. Clustering is based on the minimum distance wherever, again see, two clusters, data points. Within the cluster, you have maximum similarity. Between the clusters, you are having maximum dissimilarity. Clustering based on the minimum distance means the distance between this data point is minimum. That is why they are into one cluster. And in this way, you perform your k-means clustering. You keep on repeating the steps until your k cluster or the centroid, it doesn't start moving or jumping from this cluster to this cluster. If it is doing that, you again repeat this step of choosing the centroid value. And the moment it stops iterating from one cluster to other, you end your algorithm. When you talk about the representation in your k-means clustering, we use a graphical representation called as dendrogram or dendrogram. Dendrogram is a diagram representing a tree. This representation is frequently used in different contexts. When you are using your dendrogram in hierarchical clustering, it illustrates the arrangement of the clusters produced by a corresponding analysis. Right? When you talk about the advantages of your k-means clustering, the main advantage, as I told you, is k-means clustering is simple, fast, efficient, and scalable for big data. And the clustering quality of your standard k-means clustering algorithm is highly dependent on the initial clustering center, less complex methods. These are some advantages that we have for our k-means clustering. But there are some disadvantages. Sometimes it is quite tough to forecast the number of clusters or the value of k. The output is highly influenced by original input. For example, the number of clusters. An array of data substantially hits the concluding outcomes. And in some cases, the clusters show complex spatial views. Then executing clustering is not a good choice in those cases. Also, rescaling is sometimes conscious. It can't be done by normalization or standardization of data points. The output gets changed in time. So it requires number of clusters in advance. You have to define k value. Problem with handling categorical attributes is also one thing. It does not discover the cluster with non-convex shape, a big issue, and result varies in the presence of the outlier. So these are some disadvantages that are associated with your k-means cluster. Talking about the applications. So it is being used almost in every domain, ranging from banking to recommendation, capital, cybersecurity, document clustering to image segmentation. It is typically applied to data that has a smaller number of dimensions, is either numeric and quantitative. Using your k-means clustering with the categorical data is a task. So now let me quickly show you the particular use case that I have done. I have taken a data set, and this is the National Stock Exchange data set, which was open source. I have used this and I tried to do my k-means clustering on that. Let us try to understand. Okay. So here, I'm importing pandas as PD, I'm importing numpy as NP, I'm importing your matplotlib as .pylab as PLP. I'm importing your k-means from sklearn.cluster. I'm importing your cdisk from spatial distance. And then I'm loading the data set. So this is the data set that I am having, and I've given it the name National Stock Exchange. Now, when I say nsc.describe, it is going to show me your count, mean, standard deviation, and minima value. When you say .info, it will show you all the details regarding various columns that it is having over here. 15 columns. It will show you all the information. Upon doing some brainstorming with my team, I came up with a decision that from this data set, I want to draw few columns which are not very relevant for my analysis. So in this particular data set, I am having columns series and date. Series and date. I am dropping these four. Axis is equal to what? When you say axis, is equal to 0, axis is equal to 1. This always denotes your rows. This always denotes your columns. So since these are in our column, so I've given axis is equal to 1. I'm running this. So right now we are having 15 columns over here. And then after dropping these two, I have my 13 columns. Now, if I say I have stored this into a new variable called as NSE1, and I'm trying to find the information of it. So I'm getting all the information. Now, I am trying to define a normalized function. And I'm saying define a function normalized for all the values and say for x is equal to take all the values minus your minimum value divided by whatever you get from subtracting your maximum and minimum, and then you return your x. Now, once this normalized function has been defined, we are using this on this particular data set, NSE1. Index location, I'm taking all the rows, but columns I'm taking from 1 until the end. So I'm not taking index number 0. I'm taking from here until the end. And now if I say df underscore norm, these are the normalized values that I am getting. My data set has been normalized. Now I am trying to implement a clustering rule, and I'm saying total within sum of a square. I'm creating a empty variable called as TWSS, total within sum of a square, and I'm creating it as an empty variable. I'm also saying give me a range of numbers from 1 to 11 in the form of list and store that into a variable called as k. K, you are having a list of numbers from 1 to 10. Last number is always ignored. Now, what I'm doing is, I'm saying for all the values in K, use your K mean n underscore clusters is equal to I. What is I? 1, 2, 3, 4, so on and so forth. A net is equal to K means cluster and random state is equal to 0. Then I'm saying use your K means model and run this on this particular data frame, which is the normalized data frame. After you get your values or whatever values you get after applying your KV, keep on appending those values into this empty data set that you have created, variable that you have created, TWS. Let me run it. So you have these various total within sum of square values. For each of the clusters. Now, what you are doing is you are trying to plot an elbow plot. You are saying The color that you want to use is red color, and the title should be elbow method. On the x-axis, you want number of clusters. On the y-axis, you want total within sum of square value. So this is the kind of elbow plot that you are getting. By analyzing the data over here, we can see that we can use clusters from 4 to 8. So here I am going to use that. When I say df.norm head top 5 values, it is going to show me. I'm also trying to plot a dendrogram. For that, I'm importing linkage. I'm importing your scipy.cluster.hierarchy or SCH. And I'm saying use a linkage function of df on df underscore norm. Method should be I want complete linkage. And the metric that you are going to use for finding out the distance is your Euclidean method. The values that you get is store it into a variable called as z. Taking some time. And now, I am plotting a dendrogram. I have initialized some parameters, plot title, what should be on the x level, what should be on the y level. Just a moment, guys. Ah, my bad. Just a moment. It's taking a while. We have to wait until this red light stops blinking. It turns back to gray. Taking some time, guys. Kindly be patient. It will be working. Just hold on for a few seconds. In the meanwhile, let me tell you, how do we choose the clusters? When you try to find the distance is very less from this to this. But when you come up at this point, you see a fairly large distance. So you tell your machine learning algorithm that you have to start from this particular cluster. This is what we have given earlier. We are selecting 6 clusters from this particular street plot, which is the optimum number of clusters. See the distance. And using this, we are going to use that on our model. We are saying that use your number of clusters is equal to 6 and apply your k-means clustering on this. Store it into a variable called as model. And then model.fit. When you say dot fit, your particular model starts running. And you are using that on your df underscore norm. And here, if you see, you have this dendrogram. This is the dendrogram that we got. Now, I'm using your cluster 6. The idea behind doing that I told you, and then I'm trying to run it on our df underscore norm dataset, which is holding your normalized values. I'm getting the labels of the clusters assigned to each row. I'm saying model.labels. Right? I'm storing that into a variable called as labels. So if I see labels over here, these are the various labels. Maybe cluster 1, cluster 2, cluster 3, cluster 4, 5. Few clusters we came up with, and cluster 0 as well. So we chose number of clusters as 6. So labels we got as 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Total 6 clusters. 1, 2, 3, 4, 5, 6. 6 clusters we got. Now, when you see when you say labels, these are the label names that you have. 1, 1, 4, 5, 5, so on and so on. I'm saying use your panda.series on these labels. Values that you get store it into MB. Now, I'm saying in your LSC1 data set that you have over here, make a new column called as your cluster. And whatever values you have over here in your MB, these are nothing but your label values, store this into this particular column that you have created. So here we have this new column, which is holding these label values that we just created. Now, when you say NSC1.head, top 5 values, top 5 observations it is going to show you. I'm saying from this particular data set, take the index location, take all the rows. Columns take from 13, 0, 1, 2, so on and so forth. Why? Let us see. So this is your index number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I am saying take this particular index a number which is having a cluster information from here to here and then proceed with the other indexes. 13, 0, so on. Storing it into a new variable called as NSET. The idea behind doing this, when you compare this particular data frame along with this data frame, you are seeing, though we have these symbols that you see on the National Stock Exchange board, and we have done the proper clustering on this, but it is hard to interpret. But if I take this over here, it will be very easy for me to interpret that which particular symbol is belonging to which cluster. That is why I took the clustering in the front. Now I'm saying, give me the top 5 observations, it will show you. I'm saying from this particular data set that we created, take the index location from column number 2 until 30 and group by nsc2.plus.mean. Please take the average of that and do the. Now, I am taking this particular NSC2 data frame and I'm trying to convert it into a CSV file. The name that I'm giving is k-means_nsc.csv. Encoding I'm giving as UTF. Encoding is something when you save a file on your hard disk, this is a universally accepted address. Maybe this is accepted, means it is cross-platform. Wherever you will be using this file, you will be getting the exact answers. So UTF-8 I have given, and I'm saving this particular data set into a CSV file on my local machine. This is still in your Spider, but now I'm trying to save it into the local machine. Now it is saved into the local machine, but where it is saved, I don't have any. To find the exact location where it is saved, for that I have to first import OS, and then I have to say OS dot get CWD, means current working directory, and it will show me the path where this particular file has been stored on my local machine. So it is showing here it is stored into C drive users RSH with the name k-means_nsc.csv. Let us see. C drive users RSH k-means_nsc. Yeah. This is what we have, and this is what we created over here after performing the test. The same data I have stored into your CSV file. This is, guys, how you perform your k-means clustering for we have seen how to perform this on your example of, this particular capital market analysis that we were using. And in that, we have seen your National Stock Exchange data. So what we have seen is that K-means is utilizing an iterative procedure to yield its final clustering based on the number of predefined clusters. Like we defined your K clusters is equal to 6. And as per need, according to the data set and represented by the values. For instance, if we set your K values is equal to 5 or 3 instead of 6, then the data set would be categorized into 3 clusters. If K is equal to 5, it will be categorizing the data into 5 clusters, so on and so forth. So the fundamental aim was to define your K centers, one for each cluster. These centers must be located in the sharp manner, as I was telling you in your, elbow curve, because of the various allocations causes different outcomes. So it will be best to put them as far away as possible from each other. The maximum number of plausible clusters will be the same as the total number of observations or the features present in the data set. So finally, let us conclude. And K-means clustering, guys, again, it is it is a unsupervised machine learning algorithm that is part of a much deep tool of data techniques and operations in the realm of data science. It is the fastest and the most efficient algorithm to categorize data points into groups, even when very little information is available about the data. Similar to other unsupervised learning, it is necessary to understand the data before adopting which techniques fits well on a given data set. Considering the correct algorithm in return can save a lot of time and the efforts and assist in obtaining more accurate results. So guys, this was all about K-means clustering on this capital market use case. So we are winding up this session for today. Thank you so much, guys, for joining. You guys have been a wonderful audience, and we will be connecting again on Monday. Till then, be safe, enjoy your weekend. Thank you so much, and happy learning.